Okay, so welcome sa ating video lecture series sa area moment method. So sa mga three videos na example natin, pag-aaral natin how to use the area moment method in calculating the slope and deflection at a particular point. So in your module, it was presented the concept of area moment method, but let me just emphasize some of the major issues na naranasan, okay, from my past students nung nagturo ko ng struct. So, in the area method, some confusions arise between the deviation and the deflection. So, let's differentiate that. So, let's say this is your beam, okay, and then this beam deflect. Yan. Okay, so let's say ito yung A, and then we have B. So, when the beam deflect, let's say ito yung B prime. Okay? So, this is the natural state of the beam. Yung parang naka-horizontal. And then, when the beam deflect, yung deflection na to, or the deflected shape, this is actually your elastic curve. Okay? So, ito yung elastic curve natin. So, the elastic curve actually predicts the curvature of the beam when subjected to a different loading. So, yung elastic curve ang magdedetermine kung ano yung deformation ng beam at a particular point. So, meaning, kunyari, if you're going to plot, let's say ito yung x-axis and this is your y-axis. If you're going to plot the deflection at any point, let's say meron tayong deflection dyan, meron ulit deflection dito, and so on. Now, if you connect those points ng deflection, makaka-arrive ka ng elastic curve. But in consideration, we are only considering at some specific points, okay? Hindi natin kailangang i-drawing yung mga deflection at every point sa beam. So, we'll only consider some of the specific points so that we can immediately draw the rough curvature of the beam. So, yun. So, yun yung elastic curve natin. Now, when the beam deflect, let's say in the area moment method, we are actually drawing a tangent line. So, let's say if we draw a tangent line at A, so this is the tangent line at A. If we draw a tangent line at A, yan, this is tangent. So, tangent at A. Okay, so at point B of the beam, say we're going to draw a vertical line. Yan. Now, let's differentiate kung ano yung deflection and deviation. In your module, ang ginagamit kasi for deviation is merong parang AB dito. Okay, and then yung deflection naman is yan, isang letters lang. So, sa module natin, kapag dalawang letter, deviation yan. Okay? Or sometimes meron tayong sinasabi parang deviation A and then slash B. Ibig sabihin nito, the deviation of point A drawn from a tangent line at B. Ito yung sinasabi niya. Okay? So, para mawala yung confusion, yung deviation na to, or yung delta na to differentiate that with deflection, let's say we're going to use the letter T, or the deviation. So, ano pa yung deviation? So, the deviation is, when we draw a tangent line, and this is the elastic curve, this is the tangent line, and this is the elastic curve, the deviation is actually the vertical distance. Okay, the vertical distance between the point on the elastic curve, let's say point B, to a line, a vertical line that intersects the tangent line. So, ito yon. Ito yung vertical na distance na sinasabi. So, this is the deviation. Ang vertical distance ito. Okay? So, deviation, how will you write that? This is the deviation of B drawn from a tangent line at A. Okay, so this deviation distance can be determined using the second area or the second area moment theorem. How is this deviation different from the deflection? Now, the deflection is referred from the horizontal line, okay, from the centroidal axis of the beam. So, in this case, ito yon. So, this is the centroidal axis of the beam at horizontal the horizontal length or horizontal line. Ito yung deflection sa beam. So, that's the difference of the deviation and deflection. The deviation is referred from, let's say this is the neutral axis. Okay, deviation is referred from from the neutral axis. So, deviation is the vertical distance between the neutral axis and a point on the elastic curve. Now, deviation, on the other hand, is the vertical distance from the elastic curve to the tangent line. Okay, so that's the difference of deviation and deflection. Now, we have a sign convention for deviations. Okay, so the deviation, let's say this will be your tangent line. This is your elastic curve. And you draw a tangent line to this point. Okay, and this is your deviation. The deviation is positive if, let's say, point A and point B. This is a positive deviation if the distance or the deviation is found below the elastic curve. So, ito yung elastic curve. Okay, easy. And this one is the tangent line. Okay, or you can read it, the deviation is positive when the distance is, or the vertical distance is above the tangent line. So, this is the tangent line if the distance or the curve, the distance between the elastic curve is nasa taas. Now, how about the negative deviation? The negative deviation, on the other hand, if this is point A and this is point B, if we're going to draw a tangent line at A, this is the vertical distance. This is the negative deviation. Negative deviation at B drawn from the tangent line at A. How is it different from positive deviation? So, the negative deviation is when the distance, the vertical distance from the tangent line is nasa taas. So, if this is the elastic curve, and then ito yung tangent line, the deviation is negative when that distance is found above the elastic curve. So, ito below, ito above. Okay? So, we have also the sign convention for rotations or slope. Okay? So, if this is horizontal line and then we have a tangent, this is the tangent. If this rotation is clockwise, this is a negative slope. But if the rotation is counterclockwise, this is a positive slope. So, remember these sign conventions. Okay, the first area moment theorem, states that, in the deviation, the deviation of the tangent line drawn to the elastic curve is actually, so T, deviation, let's say BA, is actually equal to the 1 over EI multiplied by the area, moment of area, okay, from that particular point. Now, the question is, where is this referred? Now, if the deviation is deviation, you're talking about the deviation of B with respect to the tangent line drawn from A, your X should be referred from from B. Okay, so that is the first area moment theorem. The second area moment theorem states that the change in slope. So let's say we have two tangent lines. So let's say this is with slope, let's say slope A, and let's say slope B. The change in slope between these 2 points, AB, is equal to the 1 over EI multiplied by the area between these 2 points. Okay, area between these 2 points, so between A to B. Area of the moment diagram. So ito naman, area of the moment diagram multiplied by the moment area at that at a specific reference. So we are going to apply this. You can read the more detailed explanation of the first and second moment area theorem in your module. But we can understand it better if we have an example. Okay, so ito yung example natin. So solve natin to using the moment area. So pang warm up lang to. So yun. So una is before you draw the elastic curve, try muna natin kunin yung mga reactions. Okay, let's say ito yung mga reactions. So we have AY. Ito naman, okay, CY. Yun. So mag-moment lang tayo. So support reactions. Okay, yung mga steps na laging ginagawa, support reactions. Okay. So we'll take moment. We'll take moment sa C na lang muna. Equal to 0. So let's say clockwise positive. Moment tayo sa C. So AY times 9. We have AY times 9. Yun. And then, ito, clockwise positive. So plus 100. Okay, minus 10 multiplied by 3 multiplied by 1.5. And then minus 100 times 6. So ang AY is 60.56 kilonewton. So 60.56 kilonewton. And then summation moment sa A to solve for CY is equal to 0. So clockwise again, positive. So CY, negative CY, multiplied by 9 plus 100 multiplied by 3 plus 10 multiplied by 3 times the moment arm. That will be 7.5. 3 plus 3 plus 1.5 plus 7.5. And then plus the concentrated moment is equal to 0. So CY is equal to 69.44 kilonewton. Yun. So, meron ka ng mga reactions. Yun, pwede na. Okay. So, sulat ko lang dito, AY 60.56. Ito naman, 69.44 kilonewton. And then, kilonewton din. So, yun lang. Okay, pwede na tayo sa bahala ka na. So, saan ka magmo-moment by area ngayon? So, first step is to choose where will be your moment center. Okay, yung pinakamagandang location ng moment center. Okay, so may link akong binigay sa inyo. Okay, this is a lecture by Sir Gortera kung saan ang best location. So, paano mag-determine ang best location ng moment center. Anyway, nakalimutan ko ilagay dito. Magkaiba pala yung I. Ito 2I to. So, 2I yan. Ito I. Okay. So, 2i from A to B, and then I from B to C. So, sa lecture ni Sir Vertera, meron doon yung mga best or yung location, tips on how to locate the moment center. So, this time, I will be choosing B as my moment center. Okay? To separate ito, kasi merong 2i dito and then I. Okay? So, 2i and then I. So, one in options ko doon, kaya naglalagay ako na, dito ko pinili kasi to separate yung different property. And then, it so happened that one of the edge of the uniform load is at B. You can also choose C. Pwede lang yon, pero mas mahirap. Pwede naman yung sa C. And pwede naman yung sa A. Depende kung ano yung gusto nyo. But dito, sa example natin, gagamitin natin yung sa B. Okay, so, drawing lang natin yung mga paano yung moment diagram by parts. So, kuha lang muna ako ng reference line para mas mapabilis. Yun. So, unahin ko dito. Ito lang siguro. Oops. Oh. Okay, so dito, 60.56, sabi ako magmo-moment. So, triangular lang load to. Pag meron kang concentrated, ang moment diagram niyan is triangular. So, dito, yan. So, yung value dito is 60.56 multiplied by 6. 60.56 multiplied by 6. So, that will give you a value of nakalimutan ko yung 60.56 times 6. So, 363.36. 363. So, 363.36. And then, dito sa 100, 100 times 3. Okay, 300. Dito na kailangan i-calculate naman siguro yun. Okay, so negative 300. Then dito, 64. Ay, 69 ba yun? 69. 69.44 times 3. So, 208. 208.32. 208.32. And then for the 100, okay, tingnan mo yung response ng 100. Okay, tingnan mo yung behavior kapag ano yung magiging behavior ng beam BC. So, kung gagawin kong fix to and then you apply a moment, ito magko-concave downward. So, negative bending yon. Ito yung concavity niya. Okay? So, negative bending to. So, negative M, kaya dito siya. So, ang magnitude nito, 100 pa rin. So, negative 100. And then, para sa uniform, separate ko na lang yung sa uniform load. So, sa uniform load, magiging spandrel. Okay? Sa ang N doon is 2. Spandrel dito. Oop. Control Z. Yun, spandrel. Yun. Okay? 0 doon. So, ang N dito is 2. And then, ang ganun dito, negative 45. Yun, okay na. So, una, tingnan natin yung elastic curve. Drawing natin yung elastic curve. Letter B. Okay. B. Elastic curve. Ano ba yung magiging behavior ng beam? Or yung curvature niya? Or yung QDS? Okay, simply supported lang naman yan. Of course, magde-deflect. So, ito yung deflection niya. Okay, dito na lang. Oop. Yan, ito yung ulit yung A, yung B, and then yung C. Kasi may moment doon, so merong konting deflection dito. Okay, magka-curve konti dito kasi merong moment dun eh. So, let's say, ito yung, so, ano ba yung mga hinahanap natin? So, ito yung hinahanap natin. Okay, but, separate ko nga na kulay, mas maganda. So, B, pero ganun yung shape niya. So, ito, ganun ko muna. So, yan. So, parang ganyan yung elastic curve natin. Okay. So, i-darken ko lang. Okay, yung kulay red ang elastic curve. So, ito yung hinahanap natin. Okay, kung matanda, ito yung deflection. Okay, this is the deflection. From the neutral axis, yung line na white is yung elastic natin. That's neutral axis. So, ito yung theta or deflection sa B. Okay, so paano natin i-solve ngayon yan? So, ang first tip is always start sa 0 or always start to draw your deviations at deflection is equal to 0. Hindi kayo magkakamali pag yun ang una yung ginagawa. So, always draw your deviations where you have or where you can determine the deflection or at least given yung deflection. So, saan ba yung point natin ang alam natin ang deflection? So, point A and point C, alam natin ang deflection doon. Ang deflection doon is 0. Pero merong slope. So, yun. So, mag-draw tayo ng tangent line okay, sa A. And then, extend natin sa kung saan yung 0 deflection, which is sa C. So, i-extend ko to kung mag-create ako ng tangent line. Yun. Ito yung sa 0. 0 slope. Yan. Bakit kaya? Kaya ano kayong reason? Kasi when you do that, you can actually form a triangle. Okay? Once you form your triangle, pwede mo nang makuha yung slope ng tangent na yon. Okay? So, dito pa lang, makikita nyo na yung triangle. Ito, tama? Yan. Kaya laging mag-draw ng tangent line, i-extend nyo doon sa may 0 ang deflection. Ganon din dito sa C. Pwede din sa C, mag-draw ka ng tangent line sa C, extend mo hanggang sa A, masosolve mo na yung slope sa C. Okay, so dito na lang sa A. Okay, pinatikin ko lang. So, eto, meron ka na ngayong ganun dito. Okay, ano tong ganun to? Deflection or deviation? So, eto is deviation. So, eto ngayon yung deviation. So, deviation of C drawn from tangent line at A. Okay, ganun dito sa point B. Okay, meron din tayong deviation dito. The deviation of B drawn from a tangent line at A. And then, ito yung slope ng slope A. Ayun. So, ito unknown yung A. Okay, di ba unknown yung A? Check lang natin. Slope sa A. Okay, so, pwede na tayong mag-solve. So, yung slope sa A, pwede mo i-solve yan. So, pero kailangan muna natin. Papapansin mo, meron tayong triangle. Okay, yung triangle. Nakikita nyo ba yung triangle? So, eto. I-redraw ko lang para mas clear. Ito yung TCA. Ito naman yung sa may point B. Okay? Ito yung point B. Ito yan, yung combination ng deflection sa B plus deviation sa B tangent line from A. Ito, alam natin to. Alam natin yung distance na yan. Ito 6 meters. Ito 3 meters. Ito theta. Yun. So, if we can determine the deviation at B with respect to tangent line drawn from A, and then yung sa C, pwede nating masolve yung deflection sa B. So, yun. Dito pa lang, meron na tayong dalawang pwedeng makuha. Slope at A and deflection at A. Hindi naman natin tinatanong yung slope sa B. O yun, hinahanap pa rin yung slope sa B. So, dito pa lang, pwede na tayong mag-solve naman. So, again. Then, sa B naman, magdodraw ako ng tangent line sa B. Yun. Yan. So, ito yung sa tangent sa, so again, drawing ko lang dito at tangent at A. Ito naman, tangent at B. Kaya siguro ang haba ng oras ng videos ko kasi mas marami akong dada. So, ganito kasi ako mag-lecture kapag gano'n, mas maraming dada kasi sa sulat. Yung mas maganda kasi pag kinukwento mo, kinukwentuhan mo yung problem. So, yun. So, yun. Ito. Ano ulit to? Ito yung slope. Okay, the change in slope between A and B. Pwede nating masolve lang using the second moment theorem. Yun. So, meron ka ng free body diagram. So, yun. So, start na tayo. So, sa TCA, or the deviation. So, TCA, the deviation of C with respect to a tangent line drawn from A is equal to 1 over EI over the summation of area X. Okay? So, reference natin from C to. So, magmo-moment tayo sa C. So, ayan, kunin muna natin yung mga area. So, let's say ito yung centroid. Yan, centroid niyan. Ito, centroid din. Yung mga yellow is naka-centroid. Yan, then centroid. And then, kunin natin yung value. Okay, kunin natin yung value. Let's say A1. Hindi, dito na lang mismo. So, 363.36 times 6 times 0.5. Okay, 1090.08. So, ito, 1090.08. And then, yung distance niya from ito muna, kailangan lang natin mamaya para mag-add na lang tayo. So, 2 meters yan. Okay, para mas referred. So, ito naman, from this point, ang value nito is 1/2 to. So, 312.48 to. And then, ang distance niya from C is 2 meters. Ito, ang value nito is negative 300. And then, ang distance niya from C is 1.5. Ito naman, so balik lang tayo sa formula. Okay, meron tayong formula for spandrel. Okay. Op. So, yung spandrel, let's say ito yung ganun natin. So, ito kasi yung yan. So, ito yung height. Ito yung base ng spandrel. So, ito yung general equation, y is equal to kx raised to n. So, ang area nito is 1, n plus 1 base times height. Okay, so kung triangle yan, ang n natin is 1. So, 1/2 base times height. And then, ang x bar, okay, x bar, referred from dito, x bar, bar x is, we have n plus 1, n plus 2 times b. Okay, check natin. So, this will be n, kung 2 to, 3. Kung n is equal to 2, it will be 3/4. Okay, 3/4 of b. Or from dito, 1/4 dito kung dito ka mag-refer sa h. Okay, so kung triangle to, okay, kung triangle, ang n mo is 1. So, it will be 2/3 of b. Ayan. So, yun lang. So, dito na tayo. Okay, area nito, 1/3 base times height. 1/3 base, which is 3, times height is 45. So, 45 to, negative. Negative 45, ang distance niya is, okay, meters lahat to, meters to, baka kasi ito. So, 3/4. 3/4 of 3. Okay, 2.25 to. Okay, and then ito naman, kalimutan natin. 0.5 times 3 times 300. So, 450 to. Okay, 450. Ang distance nito from B is 1. Okay? So, kailangan natin is, so, yun, tupain lang natin yun. Okay, so, kita ko ba na? So, TCA, so, apply theorem. Okay, theorem 2. So, apply theorem 2. So, TCA, or the deviation at C, is equal to, so, 1 over EI, pero tignan mo kasi meron tayong magkaibang EI. So, 2I to, itong dalawang area na to. And then, tag-I lang yung itong mga area na yan. So, from C to A tayo, So, yan, i-ganon mo lang. Sundan mo lang to. So, para sa 1098, so, 1 over EI. Okay, so, sundan mo lang to. So, we have, for 1098, and 98.08, okay, multiplied by, okay, so 2 plus 3, that is 5. Over 2, kasi 2EI yun. Okay, so plus, yung 312.48, ang moment arm niya from C is 2. Okay, I lang yun, so divided by 1, kahit di na natin lagay. And then, yung minus 450, okay, nakalimutan ko, dapat may minus to. Kasi negative area to negative area. So, minus, so, minus 450, 450, 1 plus 4, that is, 1 plus 3, so that is 4 meters. Again, 2, kasi 2i yun. Then, minus 300, minus 1.5, and then minus 45 times 2.25. So, 2.25. Oop, yun. Yun. Okay, so calculate nyo yan. TCA equal to, so 11098.08 times 5 over 2 plus 312.48 times 2 minus 450 over 4 times 2 minus 300 times 1.5 minus 45 times 2.25. Approximately 1899. Okay, 1899.91 over EI to. Okay, over EI. So, hindi muna natin calculate yan. So, from this triangle, yung malaki, okay, so sa malaking triangle, pwede natin sabihin na ang theta A is equal to rise, which is TA, over the distance from A to C, which is 9 meters. Yun. So, ang theta A is 1899.91 divided by 9 over EI. So, theta A is equal to 211. So, 1899.91 divided by 9. So, 211.10. 10 over EI. So, kung gusto mo i-calculate na yan, okay, so, ang unit nito is kilonewton per meter square. So, mamaya natin calculate ito. So, in terms of EI na lang po muna. Okay, in terms of EI mo na lang muna. Ito yung delta A in terms of EI. Pwede natin kunin mamaya yung exact. Yun. So, yun. Next. Letter C. Saan ko kaya pwedeng ilagay yung C? Dito na lang. Okay, letter C kasi hindi pa sa malaya. So, next step natin, nasolve na natin yung slope at A. We can also determine the deviation sa B and A. Kasi para makuha na natin yung deflection sa B. Okay? So, makukuha natin yung deflection sa B once we can determine the deviation at B. So, kunin natin yung deviation B, A. So, 1 over EI, diretso ko na. So, yun. So, ito. So, AB lang tayo. AB lang. Ito lang, dalawa lang kukunin natin. So, 1090.08. 1090.08. Okay, multiplied by 2 meters kanina yun eh. Okay? And then minus, take note, ang EI nito is 2 EI. And then, itong area na to, 450. Sa A to B lang tayo. Okay? So, 450 times 1. Minus 450 times 1. Yun. So, TBA actually equal to, so 865 divided by 2 pala to kasi 2 EI din yan. So, 865.08 over EI. Again, kilonewton ulit to. Kilonewton cubic meter. Unit yan. So, again, using this similar triangle, ito. Okay, so, delta or theta A kanina to eh. Theta A, okay, itong triangle na to, theta A is equal to, or ito, kung nakikita nyo itong triangle na yan, theta A, similar triangle or ratio and proportion, theta A is equal to the deflection at B plus the deviation at B divided by 6. Kasi ang A to B is 6 meters. So, yun. So, pwede na nating masolve yung deflection sa B. So, 6 theta A, ang theta A natin is, nasolve na eh. Yun, 211.10. 0.10. Okay, minus TBA which is 865.08. So, theta B is equal to, okay, baka makalimutan yung ganun EI. So, may EI pa rin dito. So, theta B is 401. Theta B daw, delta B. Ba't theta ako ng theta? Delta B is 401.52 EI. Yun. So, pwede mo na i-calculate ito. So, ang unit ito is kilonewton cubic meter. So, delta B or the deflection at B is 401.52. Okay, convert ko to ng Newton mm cube. So, times 1,000 raised to 4 Newton mm cube divided by yung EI. Ano bang E? Okay, 68.95 gigapascal. So, 68.95 or 68,950 kasi mag-multiply yung 1,000 para maging Newton mm squared. Okay? Multiplied by, okay, yung I is 500 times 10. 500 ba yan? 500 times 10 raised to 6. mm to the 4th. Ayan. So, delta B or the deflection at B is equal to 11.65 mm. Yun. Okay, so ang deflection nito is pababa. Yun. Okay. Letter D. Ang dami namang step. Okay? So, kayo na bahala mag-ayos ng step. So, dito, kanina, nag-draw ako ng tangent line sa B and then sa A. So, dito meron siyang slope. I-redraw ko lang yon yung green. Ito yung green. And ito yung yellow. Okay, yellow. So, ito yung change in slope kanina. Okay, change in slope. Theta AB. Ito yung tan sa A. Ito yung tan sa B. Okay, so from the horizontal line, which is saan naka-refer yan, Ito yung slope ng B. Okay, theta B, ito naman, theta A. So, from that relationship, masasabi mo, ang change in slope of AB is slope at A plus slope sa B. Meron na tayong slope at A. Ito ang hinahanap natin. Pero we can determine the change in slope between AB. So, apply mo lang natin yung apply first theorem. First moment theorem. Okay, first ito. May T dapat yun. Yan, first moment theorem. So, the first moment theorem states that the change in slope is equal to, okay, 1 over EI, yung area doon, in between AB. So, yung area between AB is, ito, 1090 saka 450. So, 1090.08 over 2EI, so 2, minus 450 over EI. Ayan, pwede na natin, or change in slope is equal to, okay, change in slope, 2, ba't may EI doon? Wala yung EI dito, dapat 2 yan. Okay, 2. Okay, so, 2EI, anong sagot? So, theta B is, nakalcue ko, nakalcue ko pala. 1090.08 minus 450 divided by 2. So, ang sagot is 320. Okay, 320.04. 04 over EI. So, pag nakuha na natin yan, 320. So, so theta B now will be, so theta B is equal to, yun. So, theta B 320.04 minus 211.10 over EI. So, meron ka ng theta B. So, ano yung theta B? 320.04 minus 211.1. So, 108. 108.94. 108.94 over EI. Yun. Mamaya na natin i-calculate yung mukha in terms of radians or in terms of degrees. Convert natin to degrees mamaya. And then, kailangan pala natin yung sign. Ang direction ng theta B is from the horizontal line. Yan. So, theta. Yan. E dito naman, yung theta A, ang direction nito is, ito yung horizontal line, pag ganito siya. Yan. And last, but not the least. Okay. Saan ko ba pwedeng i-ganan? Okay, let's say, dito na lang. So, mag-draw naman ako ng tangent line dito sa may C. So, if I'm going to draw a tangent line sa C, yun. Yan. So, ito yung tangent at C. And then, meron tayong change in slope dito. Okay, meron tayong change in slope. Change in slope between A and C. Yan. Pero i-redraw ko na lang yun. Alangan dyan naman tayo mag-free body diagram. Okay, dito na lang. E na lang siguro dito. Okay, E. So, i-redraw ko lang yun. Okay, pag ganito kanina yung E. And then, pag ganito naman yung A kanina. So, ito yung tan at A. Ito naman yung tangent sa C. So, ito yung change in slope. Okay, between A and C. So, ito yung horizontal line natin para for reference. Yan. Yan. So, dyan naka-refer yun. So, ito yung slope ng C. Gamitin ko ng kulay. Na kulay ang buhay. So, slope sa C. Ito naman yung slope sa A. Okay. So, pwede ka na maka-arrive ng relationship dyan. So, theta is change in slope between A to C, between the tangent line at A and C is equal to slope sa C plus slope sa A. Nakuha na natin yan. Ito, pwede natin kunin. Okay? So, yung change in slope from A to C is equal to 1 over EI. Anong theorem to? Theorem number 1. So, add mo lang yung mga areas. Okay, balik lang tayo. Yung mga area, ito. Hindi ko na maalala. So, 1090, sulat ko lang muna. 1090.08. Okay, 1090. Okay, so 1090.08 over 2. Okay, and then minus 450. 02 din yon. 450 kasi nasa 2i din siya. And then the rest is i na lang. So positive to, 312.48. 312.48 tapos 300 tapos 45. So, isang 312.48. Isang 300. And yung 45 na spandrel. Yun. So, positive yung 312. Positive pala yun. So, positive area. Buti na lang select. So, ano pa? Baka mali yung isang area natin. So, dalawang positive, tatlong negative. Dalawang positive. Pero itong 312, 300, saka 45 na sa I. So, hindi na natin nalagay yung 1 over 1. So, change in slope between A to C is equal to 287.52 EI. And then, change in slope. So, ito. Ayan. So, slope sa C now will be 287. Okay, 287.52 over EI minus 211.10 over EI. So, slope sa C, yun, tapos na. 76.42 over EI. Anong direction nito? Okay. Counterclockwise. Yan. So, counterclockwise. So, nasolve na natin lahat. Okay, so i-convert natin to degrees. Kaya lang, before that, may ito. Pag ang theta A, ang theta is, ang unit nito is kilonewton mm squared. Okay, so kilonewton mm squared. Now, let's say ito, 211, theta A, kita ko lang for the meantime. So, 211.1, i-convert natin tong kilonewton mm squared ng newton millimeter squared. So, magmumultiply ako ng 1,000 raised to 3. And then, Ito sa 98 gigapascal ay sa gigapascal 68.95 yung GPA para maging Newton. So 68 mag-multiply ng 1,000. So 68,950 Newton mm squared. Ito Newton mm cube na. Mm cube daw, mm squared. And then, yung 500 times 10 raised to 6 mm to the 4th. Okay? So, times 180. Multiply natin ng 180 over 5 para maging degrees. So, anong sagot dito? So, 211.10 times 1,000 raised to 3. 68. 68.95 times 500 times 180 over pi. So, 0.351 degrees. So, ang rotation nito is clockwise. Okay, dito, mapapansin mo, itong unit natin dito, kilonewton meter squared. Pag magmumultiply ako ng 1,000, so 1,000 raised to 3. And then yung GPA, yung E, in terms of GPA, para maging Newton, nag-multiply tayo ng 68.95, nag-multiply tayo ng 10 raised to 3. And then, sa E, so 500 times 10 raised to 6. Tingnan mo, pag pinagsama mo to, okay, magiging 10 raised to 9. Ang 1,000 cube is actually raised to 9. 1,000 cube, okay, times 10 raised to 9 mo, okay, 1. So, ito, actually equal to 10 raised to 9, 10 raised to 9, kaya nagka-cancel. Kaya, para consistent, para ito na lang gamitin mo, para hindi maraming numbers dito. Pag ang E is in GPA, and then ang I is naka times 10 raised to 6, and then yung ito, yung nakukuha natin do, as long as yung unit ng force mo is kilonewton, and ang distance is in meters, pwede mo na lang siyang isulat na ganito. So, theta B is 108.94 divided by 68.95 multiplied by 500. Okay, parehas lang yung sagot dyan. So, times 180 over pi. 108.94, 68.95 times 500 times 180 over pi. So, 0.181. 0.181 degrees. Ang rotation nito, counterclockwise. And theta C is 76.42. 76.42 over 68.95 times 500 times 180 over pi into times 180 over pi. 76. Malaki naman yun. 76.42, 68.95 times 500. So, times 180 over pi. 0.127 degrees. So, ang rotation nito is clockwise. So, yun. Kompleto na. So, ganyan lang ang area moment method. Okay, so thank you. See you sa next video lecture.